For this presentation, we will discuss the Greeks. This is a catalog of our presentation. First, we will do a brief introduction of the Greeks, and then we will talk about delta, gamma, theta, and vega. So we all know that futures contracts can be an effective and efficient risk management or trading tool, and their performances and prices are affected by several factors and dimensions, such as interest rate, volatility, passage of time, and the direction. So the Greeks are just metrics to measure each of these different impacts. Delta is the most common used one. It is the change in the options price due to the change in the underlying futures price, and it is a percentage measurement. The delta of a call option is always between 0 and 1, and the delta of the put option is always between -1 and 0. If we long a call, we will have a positive data, and if we short a call, we will have a negative data. For put options, it is just the reversion of the call option. And remember, the delta of a future contract is always 1, and the delta will be higher. The highest one it is in the money. So let's say we sold 8 call options that each of them has a delta of 25. We have a delta position of -200. To be delta neutral, we need to buy 2 underlying futures contracts. And also assume we have a call option priced at 1 and it has a 0.5 delta. This means whatever the change of the underlying future is, the option will move by 50% of that change. Let's say the futures price moved from 96 to 97.5. So there's a 1.5 point move. So the options premium will now change by 50% of 1.5, which is 0.75, making the new price of the option be 1 and 1.75. So gamma is considered as the delta of delta, which means it measures how delta itself changes with a change in the underlying futures price. And it is usually expressed as a change in the delta per 1 point change in the price of the underlying. Different from delta, it is will be highest one at the money, and different from delta, all options have positive gamma values. So how to calculate the gamma? We just use change in delta divided by the change in the price. So for example, let's say we have a underlying futures contracts priced at 200 and the strike price is also at 200. And the options delta is 50 and the option gamma is 3. If the futures price moves to 201, the options delta is changed to 53, and if the futures price moves down to 199, the options delta will be 47. So what is the value of gamma? This is very basic. We will see that the options data will be 53 when the futures price increase and be 47 when the futures price decrease. So the difference between the delta is 6 and the difference between the price is 2. So the value of the gamma is 3. Now is for theta. Theta is the options sensitivity to the passage of the time, and it is also the highest at the money, and different from gamma. All the options have negative theta. The last one is vega. Vega is a Greek that measures an option sensitivity to the implied volatility, and it is also the highest one at the money. And the vega can be calculated as if we use the change in volatility divided times the vega, we can find the change in the value of the premium. Let's say we have a 20 implied volatility, and if the value of the volatility increase to 21.5, we will find the difference between the volatility to be 1.5, and we use 1.5 to times 0.12. We will find a change in the premium be 0.18, and if the value of the option is 7.5, the new option premium will be 7.68. Okay, so we think that understanding of how the options Greeks work is very important in business world, and when you want to do some tradings. So we think this presentation can help you better understanding of the Greeks. Thank you.